sealing technologies are steadily gaining importance as more and more complex components made from a variety of materials need to be combined. The dispensing process can be simulated and programmed with ABB's powerful offline programming software, Robot Studio. Within minutes, the user obtains a real program, a unique and unbeatable solution for the digital factory of tomorrow.
Scientists are using hydrogels, which are gels mostly made up of water, to make the next generation of soft electronics and soft robots. Their inspiration is nature, where hydrogels abound. A hydrogel and an elastomer, a rubbery material, are combined together with the new glue. You can stretch them by 1,000% and they still don't come apart. And the layer of glue is so thin that it doesn't disturb the mechanics of the materials. Next, researchers built several prototypes using this glue. An electronic skin complete with battery, Bluetooth, processor, heaters, and temperature sensors. The components are bonded onto a hydrogel, which wraps around the skin. Because hydrogels are permeable, you could deliver water-soluble drugs through the gel to the surface of the skin. Hydrogel disc replacement in the spine is already happening. But with the new adhesive, you could assemble this mix of hard and soft structures much more quickly. So with tough hydrogels and this new super glue, we could see a wave of soft technologies and soft robots that are even more lifelike.
The company presents many new robots, for example, a swarm of ants that can interact with each other, as well as butterflies and dragonflies, which are characterized by all the ease and grace of these insects. When they were created, the company focused not only on their appearance, but also on behavioral characteristics. The ants coordinate with each other all their actions and movements. Each ant, that is 13 centimeters long, has on its belly a radio module through which precise coordination is carried out. A 3D stereo camera in the head of the ant allows it to see, and the infrared optical sensor installed below monitors the movement of the mini robot. Meanwhile, 2 onboard batteries provide up to 40 minutes of wireless ants work, and they are recharged in the dock with the help of their antenna. As for butterfly robots, the weight of each butterfly is only 32 grams. This includes 2 servos, a pair of small batteries, and a laser-made casing. After one charging that lasts 15 minutes, butterflies will be able to flutter for about 4 minutes. Robotic seagulls and dragonflies that can fly just like their living relatives. The seagull was developed in 2012. Later, a dragonfly that can hang in the air, no worse than its natural counterpart, was invented. All the details of the dragonfly were made on a 3D printer, and you can control this miracle with a smartphone. Through these developments, the company could edge out the development market of flying drones, but it doesn't need it. The technology of flying and hovering in the air is worked on these 2 prototypes. At the core of the bionic kangaroo is a mechanism of repercussion. It uses the energy recovered from one jump to help it make another. Real kangaroos quickly get tired and could not jump for a long time without this mechanism. Springs that store mechanical energy on the landing and give it away on the next jump are used in this project. Bionic kangaroo that weighs 7 kilograms and highs 1 meter can make a jump of 80 centimeters in length and 40 centimeters in height. The power supply system that forces it to move is a pneumatic accumulator. The robot is controlled by a special bandage that reads myoelectric signals from the human forearm. Of course, Boston Dynamics is engaged in the development of robotic organisms. Nowadays, this is a kind of Skynet from the saga of the Terminator. The U.S. military today is able to catch up and destroy any person on this planet. And their new robot looks like a cross between a medium-sized dog and a giraffe. It can run, walk, sneak on half bent, and can even bring you something to drink. It won't refuse to clean up, throw garbage into the trash can, and put dirty dishes into the dishwasher. At full charge, it can work up to 90 minutes, chasing the house, collecting garbage, and according to the video, make fun of the owner. The robot is wired with sensors that allow it to navigate in space and successfully carry out the tasks assigned to it, and it can easily climb stairs. Robot Cook. This is not an animal as you might think, but the invention is so cool that it can become one of your favorites in the future. A robot that knows how to cook different foods no worse than a real person. This miracle looks like two hands attached over the hob that can use any kitchen appliances, exactly copying the actions of a person. At the presentation, the robot cooked soup for the participants, spending only 30 minutes. Also noteworthy is that the system is controlled using a smartphone and scopes recipes from the net. It is reported that this robot is able to copy the movements of a cook's hands, shot on a video camera. In the version for sale, there will be a refrigerator and storeroom where the cooking products will be stored, and a robotic cook will put the dirty dishes into the dishwasher. In order to not frighten people with a RoboCop that waves with knives in different directions with great speed, the developers have made the robot chef slower than the average person. Fish is another underwater inhabitant and environmental controller. How to control the level of water pollution. You can take samples, take it to the laboratory and analyze. And you can use a specifically designed robot in the form of a fish that will float in the water and check its purity. Robot fish tests were conducted in the port of the Spanish city of Giljan. At this stage, it was checked how effectively they are able to determine the degree of water pollution and help to recognize the main sources of pollution.
The Internet of Things. In case you've forgotten, that's a term that describes a world filled with sensors and actuators and robots and computers that are all networked together and able to communicate with even larger networks. The Internet of Things is much, much bigger. Let's really think about the potential for a world filled with devices that can detect changing conditions and react so quickly it makes the blink of an eye look like an eternity. You're driving down the street on your way to work, and you're using your car's navigation system to give you turn-by-turn directions to cut down on commute time. Your car is communicating with sensors embedded in the environment, telling it the presence of other cars and bicyclists, even a pedestrian crossing the street 2 blocks ahead. Your car's also in constant communication with the city's traffic system. All of these sensors are working together to give you a smooth commute experience, cutting down on things that would frustrate you and funneling you through the best route, clearing your path of red lights and other delays. The Internet of Things is going to enter industries like manufacturing and shipping, making them adaptable and responsive systems and increasing their efficiency. And with increased efficiency comes lower costs. It's an incredible vision of the future. To get there, scientists, engineers, and researchers are going to have to overcome some big challenges. We've talked about spectrum crunch on this show before. There are only so many wireless frequencies we can use, and you can actually hit capacity within any given area. Now, the good news is most of these devices in the Internet of Things are speaking in very small amounts of data. But when you have millions or potentially even billions of devices talking, it adds up pretty quickly. Then there's the cost. Now, the components in the Internet of Things are still under development. Like sensors, they're pretty expensive, and other elements within the Internet of Things are even more so. So bringing costs down is one of the largest challenges we face today. Personally, I don't think any of these challenges are insurmountable. In fact, in 20 years' time, I think a lot of the things that frustrate us today will be a distant memory. No more traffic jams. No more leaving the grocery store and then realizing you forgot that one ingredient you needed to make dinner. And 20 years from then, I don't know. Do you think maybe good luck will just fade into obscurity? It won't mean anything anymore because that's what our lives will be? Sure hope so. Now, it's no secret that I'm an optimist, but I think this is a future that's worth striving toward.